Welcome to Chapter 8, Covalent Bonds. Last chapter we talked about ionic bonds. We're going to build off of those, go into covalent bonds. Alright, let's talk. What's the difference between ionic bonds and covalent bonds? Ionic bonds, hopefully you remember since you just took the test on it, ionic bonds took something off the periodic table that were the metals, joining with something that was a non-metal or a negative charge, so a positive and a negative, and they were giving and taking electrons from each other. Covalent bonds, they're actually going to share electrons, and you're going to join from the carbon group 14 through the halogen group 17, and
So
you're going to
mostly
join
nonmetals.
these. Yeah, all your nonmetals issues down in here.
Your metalloids, they can go either way, so they get a little tricky.
And then there's a
Ionic or
couple
covalent.
exceptions in there, but we'll get to those once we actually get some more practice. But for the most part, you're going to have your nonmetals joining together, and they're going to share to become stable and to get to 8. It's really kind of a pseudo 8 where you're sharing, the electrons are going to move between both atoms around, and nobody's really got a full 8. You just keep moving, the electrons keep going, and as they circle, they've got their 8 and they're happy. Now the difference between naming things here, we're going to talk in Chapter 8 now, everything is going to be called a molecule. Everything in Chapter 7 was called a compound when it was ionically bonded. Now we're going to be calling them molecules. Big difference.
Yes.
See if they can catch it.
We'll see.
Alright, on how we're actually going to draw these and put them together, easily for you to see it, we're going to use our dot diagrams. You're going to do periodic table, again, use the dot diagrams, you're going to figure out how many dots each one of these atoms has, and then you can actually see them bonded together. So in our top first example, we have 2 hydrogens. Hydrogen is always going to covalently bond because it only has 1 electron. If it only has 1, it can't give it away in an ionic bond, so it has to actually share with somebody else. So here we've got 1 hydrogen with the other hydrogen. They're going to bond together and fill their outer shell and get 2. So it's kind of an exception. It only needs 2.
Sometimes people get confused if they say CHCl because they think H is a metal and so it's an ionic bond. It's not ionic because hydrogen is a nonmetal.
Right.
So it's bonding nonmetal to nonmetal. It's
Yeah,
covalent.
it's still red on your periodic table even though it's found way over here. We'll also use it when we make our acids here in the next couple sections. Another example, they took the fluorines together and they're going to make fluorine gas. 2 fluorines together would be your F2 molecule. We're going to have 7 valence electrons. I know that because it's in group 17, the halogens. Each one has 7. All they have to do is fit into where their open position was, and now everybody has 8. The next one down is a carbon with 2 oxygens. This is carbon dioxide. Naming's just a little bit different here because we got the dyes now coming into play. We'll get to that as well. But here what we have, carbon is in group 14. In group 14, it's got 4 valence electrons. With those 4 valence electrons, it's going to pair up with oxygens, and it's got 2 oxygens there.
You can see carbon has 1, 2, 3, 4. So they're all spread out right now. But it needs to pair with 2 oxygens. And so over here, you can see we've just moved the carbon electrons over so that now we can share with oxygen.
Yeah. So we'll be moving the dots around. So how you used to draw them might be drawn just a little bit different so we can move them to open positions and show where the things are going to fit just like a giant puzzle piece.
But the reason we draw them all in certain ways is so that it's easier to move and you can see what's going on.
Yeah. The next one's real easy with the carbon and the 4 fluorines. Now it's called carbon tetrafluoride because tetra means 4 and we got 4 fluorines around the carbon. So each one of carbon singles will join into fluorine 7 and fill in that open spot, and we'll get to 8. So everybody count up has 8 and everybody's happy.
Also, if you look at your oxidation numbers, carbon is going to be a +4 and fluorine is a -1. So to make that even, you need to have 4 fluorines for every carbon.
Yeah, there you go.
It all works.
Yep.
Oh gosh.
So Mrs. Kelly gets to draw.
Yay.
We are going to practice drawing some
going
drawing with the lone pair. Now lone pairs mean when you are
It's backwards.
oh,
Sorry, technical difficulties here.
when you are drawing the central atom, we're going to put the element that has the most open positions into the middle. That's called the central atom. So right now we're going to use the nitrogen. Nitrogen has 5 valence electrons.
Okay.
So it's going to go 2 dots on the top, or we're going to use X's so that we can show the dots on the iodine. and then 3 singles, 1, 2, 3. So that's got our 5 valence electrons, or our 5 dots. Now we've got 3 iodines to put in it. Iodine is in the halogen group. It's got 7 valence electrons. So she's going to put 7 dots around, hopefully. Maybe 1, 2, 3, 5, 6, 7. Now notice we've got an X and a dot paired up. That is where our bond is actually going to take place. When we draw our final drawing, so this is kind of a rough practice drawing.
Oh yeah.
And then what we're going to do is we're going to get rid of all the electrons on the outside atoms. Those are called your terminal atoms. So we've got the central nitrogen and we've got terminal iodines on the outside. We replace where we've got the one from nitrogen and the one from iodine with dashes. They're single bonds. It's a single pair together. Now, Mrs. Kelly's writing...
So one line means a single bond.
Okay. And you're writing those 2 dots in the top, and those have a special term. Those are called a lone pair, where they're not paired up with anybody. They're just 2 electrons that are towards the top.
But that's okay that they're alone. They're fine.
Yep. Let's do another one where it shows us a couple more lone pairs.
One thing about drawing these big ones, this actually is helpful because if you add up your electrons, your valence electrons, you should have the same amount that you started with. So you should have 21 electrons from iodine plus 5 from nitrogen. So if you count all of your dots, you should end up with, what would that be, 26? Okay. Anyways, side note. Sulfur is only 1, chlorine has 2, so that tells me that sulfur is going to go in the middle.
All right. It's also got 6 valence electrons, so it's got 2 open positions. Yay! You're getting so good at this.
Okay.
And then we got chlorine, and chlorine has 7 valence electrons. It's a halogen. So they're going to come into play. La la la. I would suggest maybe using colored pencils or a pencil and a pen so that when you see where the dots are coming from, if you don't want to make your X's or whatever, you could still do dots, but they're different colors. That way you can see where they pair up. So now what we're going to do is replace the chlorine and the chlorines. The pairs now are single bonds, and we have 2 lone pairs off the central atom. The atom in the middle where the chlorines are attached, that's the central atom. We got 2 lone pairs.
Sometimes you'll see it like this too.
That's typically how I like to draw it, because then the lone pairs kind of move to the top and they push everything down.
So it's the same thing. We've just kind of rotated the chlorine over. And when we get into our drawings, this is how it will look.
Yep.
We are doing drawings?
Oh, you'll be drawing.
Oh, yeah.
This is called
Is it
bent.
this chapter?
Oh, yeah.
All right.
Lots of drawings. All right. Let's talk bond types. So if we've got a single covalent bond, they actually give that a wonderful name. The single bond is called a sigma. If you've got any bonds over a sigma, such as a double or a triple bond, we build a sigma, and then the other ones are called a pi bond. So let's draw our O2. O2, we're not going to do all the dots. We'll show you in class how these work to save a little time here.
Yes.
O2 is double bonded, and if we've got a double bond, one of the bonds is going to be a sigma, the other one is a pi, so we would say O2 has 1 sigma and 1 pi.
What's the symbol for sigma?
Sigma is a circle, like a
Oh,
cursive
that's right.
O.
So we've got like that.
Yeah, that works.
Sort of.
Yeah.
I need to practice my sigma. It's been a while.
and
then
1 pi.
I know how to do pi.
There you go.
Okay.
All right. BR2 is a single bond. So we got 1 BR bonded to the next BR. That's a single bond. And that's going to be 1 sigma bond, 0 pi bonds.
Right.
And then we're going to have this complicated one a bit. We'll see, we'll show you in class how to draw this. But it's got H is connected to the carbon by a single bond.
Using a sigma.
But then it's got a triple bond from the carbon to the nitrogen. That triple bond is a sigma and 2 pi. So we always build. Every bond starts with a sigma.
That's gonna bug
Anything
me.
over that is a pi bond. So in this case, the carbon to the nitrogen has 1 sigma and 2 pi. But it also needs to include the sigma bond between the H and the carbon. So we actually end up total within this molecule 2 sigmas and 2 pi's. You'll get more examples on that later. It's just
and I'll be
adding
better
them
with
up.
my sigma in class.
Yeah. Bond length and strength. We're going to talk about the distance between the center of the atoms all the way out to the center of the other one. What is that bond going? What's the two bonds? How long is it? Well, a single bond is actually going to be your longest one, and a triple bond is the shortest one. So I kind of think of this like a rubber band. You can take a single piece of rubber band and you can stretch it really far. But if you add a double rubber band, can't stretch it as far, it's harder.
Right.
If you have a triple rubber band, it's really short. So triple bond's the shortest in the length, and the single bond is the longest. The strength also builds as you add more bonds onto it. So a single bond is weak. Think of, you know, I always like to think of one rubber band or a guy trying to break a board.
Oh, yeah.
So you've got one board. That's easier to break for them, not for me, until you get to a triple bond. If you're going to break three, you've got to put in a lot more energy to break those three boards than you do on a single board.
Right.
So the bond strength increases the more bonds you have. When the bond is broken, energy is given off, and that's called exothermic. So we did the Bag Lab way back in chapter 3.
Yes.
We gave off an exothermic and an endothermic.
Remember when it got really hot and you kind of freaked out about it?
Yeah.
That was exothermic.
And then on the other side, it kind of felt cool.
Right.
We had an endothermic. Well, how do we get an endothermic? It's when energy is needed or absorbed to break the bond. So we were just breaking a bunch of bonds in there. If energy was taken in or energy was given off, you've got exothermic or endothermic reactions going on.
Exothermic, I like to think that energy is leaving the system or exiting, and endothermic, I like to think energy is needed in the system. So endo, in the system.
Nice. There are 2 wonderful videos. One's a summary with a song, of course, for the differences in ionic and covalent bonds. Hopefully this will help you know the difference, because that's one of the biggest questions I always get. Is it ionic or is it covalent? You should know the difference. Ionic, something from here joining with something over here. Covalent, something here joining with something also from here. And then we're also joining in one of the best bond length and strength videos you will ever see.
These links will be on our websites.
All right, later.
It hasn't paused yet. I love it. Let's just exit. We're gonna close this thing down.